Now we can use our understanding of the physics of how fires spread to look at the effect of things like wind and topography, mountains. So one thing that's well known is that fires spread much more rapidly uphill. If you see a fire near you and you're out in the bush, don't go to the top of a hill, it's going to go much faster, go downhill as much as you can. And why does fire spread uphill? It's not because the flames move uphill particularly, it's because imagine a fire on the sloping surface. If you're on this side of it, because the fire is leaning towards you, it's going to subtend a much larger angle than if you're down here. So the radiative heating is going to be much more. You can see anything from that angle to that angle. That's like a third of the sky is covered by fire if you're here. So you're going to get a huge number of kilowatts of radiation hitting you. Whereas down here you're going to get a much smaller amount. So the higher radiative heat will dry things out, warm them up, then set them on fire much more easily when the flame is closer to them because of the larger angle, and that's driven by the increase in slope, we believe. Now a similar thing happens when you get wind. So when you get wind, a fire burns at an angle, which means that if you're on this side, once again the fire is closer to you and covers a larger solid angle, so it's going to generate more heat. So as you'd imagine, the fire will go faster this way. It'll still go the other way to some extent, but fires definitely spread faster downwind. And this is used by forecasters in the traditional way, which you'll see doesn't quite work, to model how a fire is going to spread. So here I've given a suggestion of 3 different days. On day 1 there might be no wind, so a fire starts at this red dot here, and because there's no wind, the fire will just come out and radiate in all directions, and so you get a steadily increasing circle of fire moving around, and so you get the fire spreading in a circle in all directions, assuming there are no slopes or anything else. Then on day 2, let's imagine a wind started off, a wind blowing in this direction. So in that case, the fire is going to spread faster on this side and less or not at all on the other side. So it's going to elongate. It'll make a run, if you like, and so you end up with a very elongated fire front. A really dangerous situation is when the wind changes direction, which often happens in the evening with southerly busters in Australia, because if that happens, a fire that's spreading in a narrow strip, if the wind, like on day 3 I've suggested, suddenly changes to this direction, it can then suddenly advance on a very wide front. So these changes of wind direction are where things are very dangerous because they can cover huge amounts of area and be unpredictable. Of course, if the fire was just going in this direction, you knew there was a wind coming, you might try and put in a fire break here. Or you might, if that's too dangerous, work along the sides so that when the wind change comes, if your forecast is accurate, the fire can't then turn and run sideways. This is what happened in the Canberra bushfires in 2003. They were started off out in the mountains, and to begin with they were just spreading roughly in a circular direction because there was no strong wind. But then when the wind happened, the fire ran for town. So you see here, there's a fire spreading, not going very far, just in a circular direction because of lack of wind. And then on the 17th there was a westerly wind that carried a narrow path sideways, and then a much more chaotic wind on the following day which spread it up and down and filled in all the gaps until it hit the west side of Canberra. Another problem from wind is ember attack. Embers are small bits of burning leaves and bark that can be carried many kilometres in front of the fire front. And they actually set things on fire by radiation. So let's imagine several embers are blown into the corner of your deck. That might mean there's enough of them there that it'll set fire to your deck because the solid area of some of the wood on your deck is exposed to a large solid angle of flames. Or likewise, the embers can land in often leaves, dry leaves in a house gutter, and again if enough of them land there and are blown into one corner, that gives a large enough solid angle to set fire to the leaves in the gutter, and that can then destroy your house. And this is a big problem for firefighters because it can start new fires a long way downwind. Perhaps one of the most dramatic situations is Montague Island, now known as Baranguba, which is 9 kilometres off the south coast of New South Wales. And that was set fire by a bushfire some decades ago because embers are blown from the mainland over 9 kilometres to sea and actually hit the island and set it on fire. So it's very hard to fight against things like this. You can put in a fire break and then just watch some embers blown away over your fire break many kilometres away. And we'll see a video now that demonstrates this whole procedure and why it's so dangerous.